Okay, so let's take a look at some proofs now about how do we prove various things. In this case, we're going to be looking at images, and we're going to be looking at injective functions. Okay, so what this statement says is that let f be a function that maps A to B. Prove that if we have a subset X of our domain, and the assumption that f is injective, then this f of A minus X is equal to f of A minus f of X. So remember, we want to remember a few things. That first off, these are the images, right? So this f of A minus X, this is the image of the set A minus X. And f of A minus f of X, these are both sets, and we are now taking the difference of these two sets. So when we look at these set proofs, we're trying to show the equality of two sets. And so to do that, we have to show that they are subsets of one another. So we're going to prove that these are subsets of one another. So let's say we'll prove this one direction first. So remember, to prove that something's a subset is you take an element from the smaller one and show that it must be included in the larger one. So I'm going to say let y be an element of f of A minus f of X. Now, because we know that these are sets, this is just a set, it's the image, and this is just a set, we can now use the same definitions we had for sets. So if it's in this, therefore, y is an element of f of A, and y is not an element of f of X. So remember, if you're in the difference, you're in this one, but you're not in that one. Now we use other definitions that we remember about things like images. So for instance, this statement here, that if you're in the image, what that means is that there was something in the set that is equal, that the function gets evaluated from or to, I guess. So we would say that since y is an element of f of A, there exists some z which is an element of A such that f of z is equal to y. So remember, this y, this is an element in my codomain. This is an f of A, so that's the image of some set A, some set, in this case, the domain here. So there exists an element in the domain that gets mapped to this element there. Now, because we know this statement here, that y is not in f of x. So if we think about this, that if z was an x, right? So if z was an x, then that would mean that when we push the set x forward through our function, so if we apply the function to every element in x, z, the function evaluated z, that's going to be y, that must be equal, that must be in the image of this. So what we now see is that since y is not an element of f of x, since this is true, then z is not an element of x. Right? Because we said that if z was an x, then y would be an f of x. All right, so now we have some great things. We said that there is a z that is an A, there is a z that's not an x. So since z is an element of A and z is not an element of x, we see that z is an element of A minus x. So it's an A minus x. And then we're trying to figure out why is it an f of A minus x? Well, because z is the element in my domain that is being mapped forward, I can now state that therefore my y, which is equal to f of z, is an element of f of A minus x. And that's what we wanted to show. We want to show that y is an element of f of A minus x because we assumed that it was an f of A minus f of x. Now, I will prove the other direction in the next video.